In this video, we are going to look at one more example of using U-substitution to evaluate a definite integral. So the example we'll be looking at is to evaluate the definite integral from 0 to 1 of x squared times the square root of 1 minus x to the 6 dx. First, let's look at the wrong approach. U equals 1 minus x to the 6 is not a proper substitution. It will not lead to the antiderivative of the function x squared times square root of 1 minus x to the 6. You can try it and see what will happen. Instead, we want to rewrite this integral in the following way. For integral from 0 to 1 of x squared and then square root of 1 minus x cubed squared. We can do that since x cubed squared equals x to the 6. So now the proper way is to find, or at least attempt to find, antiderivative using U-substitution. We'll actually never get there, but we'll solve the problem along the way. Let u equal to x cubed. Du is 3x squared dx. 1/3 du is equal to x squared dx. And now let's rewrite this integral in variable u. So inside the square root we'll have 1 minus u squared, since u is x cubed, and then x squared dx is 1/3 du. Let's adjust the bounds of integration from those of x to those of u. When x is 0 and u is x cubed, u will be 0. And when x is 1, and again u is x cubed, u will also equal to 1. And that leads us to the following definite integral, equivalent to the original one in variable u. This would be 1/3 times the integral from 0 to 1 of square root 1 minus u squared du. And we can evaluate this integral without finding antiderivative. Let's look at the function y equals square root of 1 minus u squared. Look at its graph in the uy plane. So that's what it looks like. Here's a graph of the function, and in the integral from 0 to 1 of square root of 1 minus u squared du is equal to this shaded area. It's the graph is a semicircle, and the integral represents the area of quarter circle whose radius is 1. The area of the whole circle is pi. Therefore, quarter of a circle will have area pi over 4. And the integral from 0 to 1 of square root of 1 minus u squared is pi over 4. Let's return to the original integral we are trying to compute. It's equal to 1/3 integral from 0 to 1 square root of 1 minus u squared du. We already established that that is pi over 4, so our answer is 1/3 times pi over 4, which is pi over 12.